Thanks, Nikki, and thanks everybody for joining. I'm Brian Sullivan, account manager with Vector, based out of the Houston area. We got Valentine as well. He's the regional Hardy rep for us, and Valentine has been in the instrumentation industry for over 20 years. So, Valentine, I see you got some equipment right there. What are you going to show us today?
All right, thanks, Brian. Yeah. So what we have here today is I've got a couple of different instruments. The 6500 is kind of our workhorse, and that's the one that I'll be doing a product demonstration on today. This is a 6600 modular system here. This is if you have multiple scales. So if you've got an application where you've got 6, 7, 8 scales that you need weight measurement on, this is a real cost-effective solution. So you have the gateway here, and then each one of these are weighing modules that will attach to the gateway, and then we have the display over here. Both of these displays, or both of these units, are attached to this one load cell that I have here. So during the demonstration, I'm going to be messing this one up, but you should see a very consistent weight up here on this one, if you can see it. I know it's kind of small because it's kind of in the background there. So like I said, this is our load cell that we'll be working with, and then this is a fan that we'll use to generate some vibration and noise, and we'll show how our systems can eliminate that noise. So that's just an overview. And then I also have a one mount system over there that I'll bring into the picture a little bit later in the presentation. So to get started, just a little bit about Hardy before we get into the presentation again. So Hardy is a stable, mature, innovative, and strategic company. When I say stability, we are part of a $5 billion public technology company, which is Roper Industries. We were purchased in 2007. And we've been in business over 100 years. So we have been around for a while. We're part of a big company. So we've got some maturity, some stability, and we won't be going anywhere. We are innovative. If you can see here that we built the first integrated weighing module on a Rockwell platform. So we are an Encompass partner with Rockwell. That's part of the strategic part. That's how we go to market. We are an Encompass partner with Rockwell. So if you have Rockwell equipment, our product will, whenever it's plugged into the Rockwell equipment, they recognize each other. There's some add-on profiles. There's a lot of ease that you have with the Rockwell system. We are not tied to Rockwell. We have a number of communication protocols that I'll show you a little bit later in the program. But we are an Encompass partner with them. And we're also strategic by selecting companies like Vector for our sales group. Our go-to-market strategy, Vector is part of that, and we are happy to be partners with Vector. So let's get into the presentation itself. So when we look at the process and packaging industry, we find that it is built into 4 different departments. And these departments in one facility are often even separated by walls. Typically, they'll have different management, or at least team management, in each of the areas. And there's just different things, different needs. So if the input here, where you have your raw stock, the idea is that the customer would like to improve the accuracy. And we can do that by measuring and monitor the weight, and then converting that weight into level to show you what kind of level you have in your tank. When we get into the make, that's the batching and blending areas. Customers looking to optimize their ingredients and their throughput. And we do that by measuring the control, and we do that by either weight or by rate. So we have instruments that could do either one of those. And then in the filling and dispensing is part of the packing area. And here's where you're looking at the filling tolerances. How much product am I putting in each of my cans or vessels, whatever I'm filling, and trying to get the right amount for my customers, but yet not give more away than I intend to give away. So there we're also using our control by feed, controlling the feed by weight and rate. And then in the shipping area, where we are looking to enhance the capability of the product, so we're trying to measure how many bottles are in a case, how many cases are in a pallet, that type of information can all be done by weight. It is estimated that a product will be measured 7 times from the time that it hits the stock side of your plant and between the time it leaves the ship side of the plant. And Hardy supplies the solutions in all areas here. So, so what are you looking for whenever you have a weight measurement? If you want a piece of data, you want that data to be accurate, you want it to be stable, and you want it to be fast. So we're going to talk about 5 different tools that you can use. We call them the toolbox of technology to deliver this accurate, stable, and fast reading. First one that I'll demonstrate to you is what we call a C2 calibration. The industry refers to it as smart calibration. We'll show you how that's done, and we'll compare that to traditional calibration as well. Integrated technician, and that part of it, we're not going to go deep into this today because of the time constraints, but basically we have the capabilities to do troubleshooting for both vibration analysis as well as determining load cell, if a load cell is reading correctly or not, through the front panel of the instrument itself. We can get this information. And then we also have an embedded web server. As I'm working through the C2 calibration, you'll see the embedded web server. I'll be doing some of it on the front plate of the unit. I'll be doing some of it connected through the internet. So anywhere that you have a connected PC, you can access this device and do some diagnostics, troubleshooting, and get weight measurements as well. We'll show you that in the demo. Waver saver, this is what I've got, this little fan with this fan has a couple of blades cut out to cause some vibration. We're going to put that on the scale, let it cause a little bit of havoc, and we'll show you how the old way of how we used to remedy that, and then the new way with waver saver and how improved that is. And then the last thing that we'll talk about is the one mount sensors and how those make your life a lot easier on the installation and the maintenance whenever you have to go out and repair a load cell. So those will be the topics. So we're going to start with the calibration. So this is the old way of doing calibration, is you bring in a lot of weight and put it on the scale, then calibrate that scale out to make sure that it's accurate with these certified weights. This brings a few possibility of problems into play. First one, it's very relatable today as far as sanitized weights. Where have these weights been previously? Now these weights are all polished up, look nice from getting ready for a photo opportunity, but I've been to many service providers, some scale service providers, where the weights are just out in the back. You don't know where the last plant that they went to. You don't know about any sterilization or any contamination. So this is that's certainly a health concern. It's also a safety concern. Anytime I'm working with this much weight, if something goes wrong, those weights fall, somebody could get hurt seriously. So you've got that. On top of those two concerns, there's also the cost of getting all this equipment out on site, the cost of the technician himself, but a hidden cost behind this is the productivity cost. Whenever you're doing this, your scale is not in service. And so let's say you have 3 blending scales in your facility. That means every time you go to calibrate that scale, that 1/3 of your productivity is shut down. So if that's a half day, a full day of service, you've got 2/3 of your productivity. 1/3 is gone away. You're only operating at 2/3 of capacity. So let's talk a little bit about what the technician is doing when he calibrates a scale. And then we'll contrast that to how we do a smart calibration. So traditional calibration, we'll start with the XY axis, and we're going to put volts on the Y axis, and we're going to put weight on the X axis. And we'll have a 0 point, and we're going to say that a full scale for this scale, on the electrical side, full scale is 10 millivolts, and on the weight side, it's 10,000 pounds. So we just pick these numbers to make a nice, it's easy math whenever you have 10 and 10 like that. So in a perfect world, perfect scale would have a straight line slope, which would go straight through 5,000 pounds at 5 millivolts, 10,000 pounds at 10 millivolts. But in the real world, you're not that linear. You're going to have some error that is in that scale. And so this is where, when we do a traditional calibration, the technician is trying to get this capture this non-linearity that we have. So let's say that this technician comes in and he only picked up a couple of 1,000 pounds before he left his warehouse. So now whenever he extrapolates this out, so he's got 2 points here. He's got a 0 point, and he's got a point that looks about 3,000 pounds right here. So when you extrapolate that out, this is now what your line looks like. So what is recommended on a traditional calibration is that you always bring in something in the 75 to 80 to 90% of the scale's capacity. That way, whenever you do the calibration, when you extrapolate that out, you have much more, it's a better representation of what that scale should look like. It's also it's closer to the ideal scale as well. So that's a traditional calibration. That's what they're doing when they put the scale, all that weight on the scale, and then they're calibrating that into the scale. Problems, there's a couple of problems that are not captured. There's actually 3 things really that are not captured. One is the hysteresis. So just because it came on this particular line the first time, on the way back down, it may choose a little bit of a shift. Or the next time that you load it up, you may have a little bit of a shift in there. There's also a third problem that I can't really put on this graph, and that's called creep. And what creep is whenever I load the scale with, let's say I put the 10,000 pounds on this scale and I let it sit, that metal is going to settle. It will be a very miniature amount, but it's still going to settle. It's going to shift your readings a little bit. So what do we do in a smart calibration? Well, in a smart calibration, we take multiple points, 0 points, non-linearity. We make sure we grab a full scale, and we also grab some of the hysteresis, and we leave the weight on the scale for to see what kind of creep we get, and we combine all of those small errors, and we average those out. In a Hardy load cell, we guarantee that any of our load cells, when we look at those 3 errors, the nonlinearity, the hysteresis, and the creep, that we have a combined error of 0.02% or less. And what that means is that our load cells are matched. So if I'm in the middle of a batch and I decide that I've got a bad load cell, instead of throwing that batch out, I can change out my load cell and still have a good bit of accuracy because of the matched load cell. And then after the batch is over, I can do my calibration and zero the scale and have a really well-calibrated scale at that point. I'm going to show you in a slide a little bit later some of the details of that, exactly what I'm talking about when we combine all the slopes of the load cells. So another thing that we can do in the smart calibration that's typically not done in a traditional calibration or in the setup of the scale is that each load cell comes with a data sheet with all this information. In a smart calibration system, all this information is captured. This information is captured. All of the calibration information that I showed you on the previous cell, that is captured. All that information is loaded onto a memory chip and it's embedded inside the load cell itself. So when we when the controller hooks up to the load cell, it now has all of this information. It has the slope of that particular load cell with all the errors that were calculated. So, and there's 3 steps to this process. I'm not really going to go through on this step. I want to show you on the next slide, but I would like for you to see on this side. These are the combined errors of the 4 load cells that we're working with. Each one of these have a combined error of less than 2%. Some of them, I'm sorry, less than 0.02%. Some of them significantly less. So that's just one of the advantages of the system. So let's go to the next slide where we'll talk about these 3 steps in detail. So this first slide, black line is the slope of a perfect slope that I showed you in that first slide there. This would be the, the 0, the 5 millivolts at 5,000, the 10 millivolts at 10,000. That's the perfect slope. Each of these other slopes are the individual slopes. So as soon as all of this information has been gathered at the factory, and as soon as we hook up the controller to the load cells, this is the information that it has. Now, this has been slightly exaggerated because if it was truly a 0.02% difference in these slopes, you couldn't make it out with the naked eye. So we exaggerated a little bit. This is what would happen. Let's say, like I said, if you were in the middle of a batch and you determined that a load cell had failed, you went in and put in a new load cell of the same capacity. This is the accuracy that you can expect right here without doing a smart calibration. When you do the calibration, the smart calibration, the unit then sums all of these, and it brings in, now the black line is still the perfect, and the red line, which is very close because it's in that 0.02% accuracy. This is what it looks like, just with the calibration. And then the third step is to perform a 0, and all the 0 does, it does not change the slope of the red line, but it shifts it down here to the 0 mark. Now this scale is in complete calibration. So I'm going to show you this in let me move this back to. Right, so we talked, I mentioned the web server. This is that I'm showing you here on my screen now. This is the web server. It's the same. I am locked into this unit. So we're going to do some things on the front panel of the unit. And then we're going to do some things on the web server itself, let you see how that works. I will say that both this unit and this unit are hooked up to the same load cell. This one has been set up to where it will always show you the correct weight. So you'll always be able to see the correct weight on this one. This one we're going to mess with a little bit. We're going to get it out of calibration, and then we'll perform a C2 calibration. Just to show you the equipment that we're using, I've got, if you can see that, this is a 1 pound certified test weight. We'll put it on here. Let me move this over to monitor. So this would be if you're sitting in your office or sitting in your kitchen at home, if you've got a secure VPN connection. You can watch this scale in this way. So you notice I've got 1 pound here, 1 pound here. Also on the monitor, I've got 1 pound there as well. This second test weight is a little 200 gram test weight, and we'll put that one on the scale. Now, 200 grams is going to be 0.45 pounds. So we've got 0.45 pounds, I'm sorry, 1.45, the 1 plus the 0.45, 1.45 here, and 1.45 on the monitor. So everything's reading the same. We can tell that these are all connected. So what we'll do now is on the front panel of the unit, I'm going to go in and we're going to take this out of calibration. So we've got a wizard here, an up or down wizard, and we just use the up or down buttons to pick the one. We want calibration, it's on calibration. So we'll go ahead and calibrate it. Now, we can do the smart calibration as the C2 calibration, but in this case, we don't want to do that. We want to do a hard calibration because we want to mess this scale up. So we'll enter the hard calibration. Now we'll go in and say we want to do a low calibration. So it says that right now there's 0 pounds on the scale, but it says my low calibration weight is at 1.7 pounds. Now I can go in and change that, but I'm going to leave it. But what I'm going to actually do is on the scale, I'm going to put 0.45. So we've got it here, we've got it here, we've got that on the monitor. So let's go in now and say do the low cal. All right, so now this scale is reading that we've got 1.7 on the scale. This one says we've got the correct 0.45. The monitor, because it's connected to this one, also gives us a 1.7. All right, now we need to do the span weight. So let's go down to the span weight. And now it says that the span weight's going to be 5. Well, we're going to go in. Let's go in and make this span weight actually the 1.45. So that's where we really are, because we already messed with the. This one is off. This one is off. This one is correct. And of course, the monitor is off as well because it's following this one. So now we'll go in. We'll do the high cal. And now it thinks it's 5 pounds. So we've got 5 pounds there when it's actually 1.45 pounds here. So now we'll take the weight off. You can see with no weight on the scale, it's saying that we have a 1/4 pound. When we put 1 pound back on the weight on the scale, it says 3.55 pounds. We know that this is the 4.45. So when we put this one on the scale, this should read 4 pounds on the monitor and on the front scale. When we put it on, it's now actually reading 5 pounds. So we've got this scale. This one's still correct, still reading the 1.45. This scale is completely out of calibration. So let's do the smart calibration. And for the smart calibration, we're going to do that here on our front panel. And we go right into this calibration. And we just pick this C2 calibration right here. And it says there's a reference weight of 0. And we want to tell it, do a C2 calibration. It says it's complete, that it's been completed. Now we go back to monitor that. Now we have, let me move this back. Let me take this back out so you can see the weight a little bit bigger. So now we've got 0, 0, 0 on the monitor. We've got 1 pound, and we've got 1.45. So what that scale did then now, and remember too that on that that hard calibration, a possible problem that you can have on there is that if you think that your tank is empty, but you actually have some material in there, and so you do the calibration with the wrong weight values, that's the kind of problem you could end up with, is what we had going out earlier. With the smart calibration, you can really, it really handles that a lot. We can shift the value on a smart calibration. So if you had weight in there, it would shift your weight a little bit, but it would not have it non-linear like we saw it there. So I'm going to do one other demonstration right here on the material before we move away. And in this case, I'm going to add our little fan here. We're going to mount it right on the scale itself. Now the fan has a weight of 0.35. You see that here, you see it there, and you see it on the monitor. So what I want to do is I want to go ahead. I'm going to treat this fan like it's my tank. So if I'm weighing the material in a tank and I've got the scale under the tank, I don't really want to know what my tank weight is. I want to know what the material weight inside. So let's go back to the calibration. And with this on there, we still have a reference weight of 0. And let's do the C2 calibration. It says it's complete. Back to monitor. Now I'm saying I've got 0 pounds on the scale. This one's reading 0 pounds. This one actually still reads the 0.35, which is the accurate. So I'm going to put this weight on here just because whenever I plug this fan in, you'll see that it's going to bounce around. It'll probably turn and it'll eventually get settled. Hopefully it doesn't fall off, but we'll take a look at it here. So, okay. So you can see I'm jumping around as much as 20% with this fan in place. Now, the old way of doing things, let's go back here. The old way of doing things is we would just average a number of readings. So let's say that we're going to average 150 readings. And then now let's go back to the monitor, and you'll see that we've got a stable reading. If you remember that slide I showed earlier, we wanted 3 things: stable, accurate, and fast. So we've got stable and we've got accurate here. But I need to hold this fan because it's just really going to jump around if I take this weight off of it. So we've got stable, we've got accurate, but look how slow the scale is responding. It takes it a second or two to actually change the weight. Now, if I'm weighing pallets, I've got my forklift on the shipping side of my factory, and I'm just taking a pallet and I'm laying it on a 4 scale to make sure I have the right number of cases in that pallet. This reading is probably fast enough. But if I'm in the dispensing area where I'm feeding by rate, if I'm that slow, I'm going to overfill or underfill, and I'm going to slow my process down. So that's, we have the accurate, we have the stability, but we don't have the fast. So let's go back and see what we can do about that. So in the filter, now I'm going to set this back. These averages, I'll set them back. And now I'm going to turn on my waiver saver. And I've got 5 different frequencies that I can use to fine tune, plus I can change my number of averages. But I'm going to go in and show this as the first one, and I'm going to save that parameter. And now I'm going to go back to the monitor. Now I am more stable. I still have a little bit of movement. So let's go back again. And let's pick the next filter. And now let's see what we've got here. Still a little bit of movement. Okay, that's why we have multiple. Oh, it didn't change. So that's why it didn't change. It didn't change to 3.5. Here we go. So let's save that. Make sure I saved it. Now we've got the stability. It's locking dead on at 1 pound. And then whenever we hold it, move it, we've got a much faster response now. Okay, so that's showing you what the waiver saver can do for you. And you would go in, like I said, you would have to fine tune it to get exactly what you needed for your application. So that's the end of my my hands-on demonstration. Let me go back to the where we were talking about the electronic calibration. One last thing that I want to bring up about the electronic calibration Put this back in the right mode here. Is that this is a third-party bulk solids where they looked at traditional calibrations versus smart calibrations with regards to the ISO standards, to your quality management system. And they determined that the ISO 9001 standards can be met either by smart calibration or by the traditional calibration. So you have those capabilities. We didn't really get into the, because of time constraint, into the integrated technician. But what I wanted to show you is that you can do it two ways. You can do it either from the front panel of the unit itself, or you can do it from the web server IT. Now, what this information, just quickly, what this information is covering here, this would be the raw information coming into your device prior to the filter. This would be the filter after the filter. So with no vibration, you would get an okay on the raw result. If once you put vibration, you would get a fail on this. And then if you added the waiver saver, you hopefully get an okay. Now, if you remember when I put the 7.5 filter, 7.5 hertz filter, we still had a little jumping around. Very likely you would have gotten a fail on this one. Once we went to the 3.5 filter, now this one would have given you an okay. So what does this mean for you? Let's say that you're sitting in your office. I'm sorry, that was not supposed to advance. You're sitting in your office, and one of your engineers out in the plant says, "This we're having trouble with this scale." You ask, "Is waiver saver on?" You're like, "Yes, we've got it on." You pull this up and you determine that, well, you've got it on, but you don't have it fine-tuned. It's still not passing the waiver saver result. So then you can go in from your office, tweak the waiver saver, either the frequency or the number of averages, and then check the response just by having them add weight, take away weight, and then make sure that that's working for you. Other thing that we have over here is the gross weight that's on the scale, as well as the millivolt per volt. This is where you can determine if a load cell has failed or not. If you had multiple load cells, you would have 4 different readings under here. 3 of the 4 would be virtually the same, 1 would be different. And it's very easy to determine that the one that's different is the one that is causing you the issue. And the last thing is a return to 0. There is a tolerance set on this, but what a return to 0 can help you with is if the tank happens to be binding on something, and when you let the weight off, you don't get the right reading on that return to 0. Okay, so that's how you would use the IT. Again, either off of the front plate of the display or through the diagnostic view, either one of those. The last thing that I'm going to show you, and I need to move a little bit of this out of the way, is I want to show you our one mount system. So previously, anybody that's familiar with scales knows about the fixed bumper slider configuration. So what we're talking about there is that if you've got vibration, maybe you've got some vibration in this plane here, so you would put the bumper on this one. Then for vibration on another leg, you say, all right, that vibration's going this way, so you put the slider on that. The fixed one would be on the one that was basically the center of the axis where it was rotating around. This device, because of this floating head that we have here, eliminates the need for fixed bumper and slider. So you buy just 4 of these load cells, they go on any leg, so you don't have to guess which way the vibration is going on this particular one, which way it's not going. The other thing about it is this 360 degrees. So whenever I have a fixed bumper slider, if it says I've got to stick this cable out here in this direction, that could be where my aisle is. So I've got forklifts running through there. I've got people walking through there. The cord can get damaged. Somebody could trip. When I do when I have this device, I can put this in any direction that I want. So typically you would feed this towards the center of the tank where it's protected and out of harm's way. With regards to installing this, this piece here is a shipping bracket. It comes in place, and then also we tighten down these screws to, to make it all, to lock it all in place. So when you're installing this, you have 2 screws. So you disconnect those 2 screws, and you pull this this load cell. This is your load cell out of the way. And then you can do all your welding and everything. This becomes your dummy load cell. And then once you're ready, once you've got all of this installed, you simply jack it up, slide the shipping bracket out, and you're back in business. Let's say a few years down the road, this load cell fails. 2 bolts, take it out. Well, first you would jack up your tank just to give me a little bit of room to take the weight off of the cell. 2 bolts, take this cell out. Remember, it's matched, so as long as you have the same capacity, torque those bolts, you're back into business. Very quick, very simple. All right, this is a full system here, so you have the controllers. We have both the modules or the standalone home run cable, a summing box, and either load cells, bench scales, or floor scales. This is a full system. So let's say you've seen this demonstration, you like it, you want to get some of this features, but you've got a lot of scales out there, and you want to know what is my migration path. Just by changing out the controller, you get any of the Rockwell add-on profiles. So if you're interested in that, you've got that. You also have Waiver Saver in the controller itself. Adding the home run cable and the junction box, you now get the integrated technician. So that would be your migration path, starting with just the controller, adding the junction box, and then later on, as your load cells fail, you can replace those as well. Here, I just want to show you some of the different communication protocols, everything from Ethernet, DeviceNet, Profibus. We do have Profinet is not showing in here. We do have just recently released one product with Profinet. Others will be coming. A couple quick applications. This is got load cells down here at the bottom of this pump. The problem with this application is you've got a lot of weight on these load cells. That's not back here. Now you need to size all your load cells the same, but when you have this offset, shift that center of gravity. So you have to consider how much weight is going to be on these cells, plus the weight inside the pump. That's really what we're trying to find, is how much product is inside of this pump when it's in operation. So this is just a good example of why a consultation with an expert is a good idea. These load cells, you can see, are mounted here. The problem with them is that there is no support under this where the weight is coming out. Your support is out here and here. It needs to be in a direct line with this force. This would be kind of similar in your bathroom scale. Take it off your tile floor and put your bathroom scale on a rug and then climb on it. You're going to get an erroneous reading. So that would need to be considered. And then here we've got some load cells. We've got one here, got one here. There's one or possibly 2 more in the back. I can't tell if that's 3 or 4 legs. But here is you've got to worry about dust ingress, moisture ingress. So you want to make sure that these things are hermetically sealed and that they're rated for the right environment that you're going to install them. So in conclusion of the presentation, I would say we have precision instruments, some embedded technologies. We have all the connectivity for all the different communication protocols. We have ease of use, and we have low cost of ownership. And Hardy We believe that industrial weighing solutions should be easy to engineer and operate. And we believe that simplicity offers the lowest total cost to own. And that's why, we design things to be easier to install, easier to integrate, commission, diagnose, and maintain. And we showed you some of those tools that we have for that. So Brian, that's it for my presentation. I hope you enjoyed it, maybe learned something.
Great. Thank you, Valentine.
All right, well, thank you for having me.
You're welcome. Sorry, you froze up there for just a minute. So I think you're back, and Brian joined us as well. We are a bit over on time, but we do have time for at least 1 or 2 questions I will quickly ask from the audience. So first one, I noticed you showed slides but didn't give a hands-on demonstration or show the IT capabilities. Do we have time maybe for that to get a demo of those, or maybe something directly for that person that's interested?
We can do, Hardy has invested in some product for me to be able to do virtual demos. We didn't do it today. We ran over a little bit on the time. I didn't want to take any more time going into the integrated technician. So that's why we didn't show that. But we absolutely can do virtual demos. We can do in-person demos, and we can show you all the capabilities and go into more detail of exactly what we can do with the integrated technician.
Okay, great. And then we do have time for just one more quick question yet. And this one is regarding Vector's service. So do we offer any on-site service for Vector?
Yes, we sure do. We can service all of Hardy's products, and as well as any of the other products that we support and represent. Also have training capabilities with Vector University. We have a new campus that we'll be moving into here in just a few months, and we'll have a process training unit in there. We can do training classes as well.
Okay, great. Well, in the interest of time, I would like to thank everyone for joining us. I hope that you felt it was a valuable and worthwhile experience for you, and you learned something from our experts here and have some great takeaways. So any closing comments, Brian or Valentine?
No, I just want to say thank everybody for coming, and please let us know if there's anything, if you want more detail about any of these products or the features that we have and how they can be of value to you. Brian and I are more than happy to come out and help you with that.
Yeah, thanks for joining, and have a good afternoon.
Have a great rest of the day.